Hi guys, good morning. Today we are going to, I'll show you where we stopped, okay? So we have done on the physical chemistry, AX, we have done 1.1, right? See all these red things here. Okay, we have covered all the definitions of relative atomic mass, relative isotopic mass, relative molecular mass, and relative formula masses. And I've also shown you 1.3 to how to determine the relative atomic mass, AR, using the mass spectrometer. I also gave you some on the how to determine the relative molecular mass. So if you use a molecule there, use M plus 1, or M plus 2, and M plus 4. Okay, so we have talked about all this part here. Now, before I go on to moles, I want to talk about this part here, part 2. Atomic structure. Okay, we have done some of this already earlier. I just went through it because of the nuclear number of protons, number of electrons, kind of thing. Okay, so this part here we have done some of this. If you just read through here, this topic describes the type, number, distribution of the fundamental particles. Now, the fundamental particles means that the subatomic particles. The idea of subatomic particles, all right, see here, fundamental particles. It means subatomic particles. You will see this word coming up. Particles, as I said, particles, okay? Particles, okay? It means protons, electrons, and neutrons, okay? It means inside the atom, which make out of the atom impact some of the properties. Okay, now you can see here. Right, I won't read all these things here. I just want to talk about B. I just want to bring out this thing B here. The rest of them we will look into more detail. Okay, B here. Deduce the behavior of beams of protons, neutrons, electrons through electrical field. Yesterday, the lesson before this, part 2, I talked about the beams of positively charged particles. Okay, the particles here can mean like Cl positive, okay, 35, Cl 37 positive, okay, or H positive. Remember, as they pass through a mass spectrometer, they are being deflected by what field? Magnetic field. Okay, so magnetic field, my spelling is hopeless, right? And electrical field. So these two things we're going to look at. We are looking at magnetic field already. Today we look at the electrical field. Okay, now. Okay. Give some theory. Then we look at some of the questions, how they're being asked, and the variety, the depth they will go. Right. So now let's look at first the theory first. I've got in my notes here some of the questions. One of the questions I put in my notes here are a bit with the old real syllabus, and they're very tough. Okay, not say very tough, they are tougher than normal. Right? So let's look at page 25 for some of the 5. Okay. All right. Now this is the general idea. Okay, which I sort of deduced from all the things I read. So here, deflection of particles through electrical field dash magnetic field. So remember, this one here I talk about here is mainly on the mass spectrometer, okay, which means here you can see, okay, positive charged ions are deflected by the rule, okay. R is a radius. What does R means? What does big R means? Radius of deflection, okay. Root proportional. There's a lot of constants here which I'm going to deal with, okay. Magnetic field, size, and all those things, okay. M means the mass of the ion, which is a positive ion, because in mass spectrometer we deal with only positively charged particles, right? Okay. M means the mass of that particle. If it's elements, it would be the AR, okay, or the relative isotopic mass. If it's a molecule or part of a molecule, it will be the whole MR. E is the charge. Sometimes it's called Z or Z, okay, charge. Normally it's positive 1 or negative 1. Or sometimes positive 2. When you go to A2, they will give you positive 2 lah. Charge normally is negative 1 as well. Okay, for electrons. Okay. So now you can see the theory here. Okay, let's take 2 particles here. Okay. A H1 means that this is proton. This is your helium, mass 4. Of course, you will put 2 here. Okay, this 1 here. So we don't care about the 1 and 2, which is the proton number. We care about just the mass. This is the mass. Okay, this is the mass. All right. So one is light. I put it on because one is heavier. Okay. So how are they being deflected? Now let's take a magnetic field here. Okay, magnetic field. And it's constant. Everything is constant, all the variables constant, temperature, pressure, all constant. Okay, now, okay, here's a vacuum, suppose a vacuum. Now, of course, if you were to shoot a small, if you imagine a small small iron ball and a large iron ball here, same idea. Okay, shoot into here as a magnetic field here. This is a magnetic field here. Of course, the deflection, right? Magnetic field here, right? Okay. The small ball will be deflected more, you know, to here. Okay, okay. So now this semicircle here, right? You put a point here. So now this is the radius. This is the radius. It means now this radius. It means right here, R. Okay. The radius, they call it. This is the radius of deflection, and this is the angle. Beta here is the angle of deflection of the small fella of the H plus. Okay, this is H1 plus. The heavier ball or helium 4 positive, of course, being heavy, they will deflected. They will not so much bigger. Okay, that means the R will be bigger then. Okay, so the bigger mass, the bigger the R, or the less the deflection, the less the angle. Angle is less. This is for your He4 positive, not too positive, okay? It's positive, but take everything the same. So you can see here, right? When R increases, okay? When R increases, the angle deflection will decrease. That's all. See, bigger the R. So the second R will be from here, okay? Means from here. Okay, from here. Okay, this is this kind of. Okay, now. So I summarize it. You can go and look over, right? Now you look at this here. They'll ask. There's a question on this. If I shoot into here, right? Or they should put neutron as well. Neutron, okay. Electron. Now remember this is 1, 0. Okay, you want to put the proper way of presenting that. This 0, all right, is no, well, almost 0, 1 over about 2,000. This is not -1 here. Electron, and you got H, 1 positive. You got another deuterium, the other radioactive hydrogen, also plus. So you can see as you go through here, of course, the neutron will pass by undeflected. Even got mass, the neutron here. Okay, 1, 0 here. So that is a positive. Now remember, this is an electrical field, not a magnetic field. Okay, positive pole and negative pole here. So electron will be deflected here, right? Towards the positive pole, electron. All right, now the angle of deflection. Okay, now this is the H1. Right? Now the angle here is just approximate. Okay, I will show you afterwards how they actually ask you to calculate. Right? Now, so this one is deflected. This one is deflected more. This is the most one, right? This one is most biggest angle of deflection. Why? Because it's the lightest. Why? Because it's the lightest. Okay, right? Now this fella here is deflected less. Okay, less angle here, right? And of course, it's the least, right? This is the least. This one here. So this is the biggest angle. Okay, now this is the biggest number 1, right? Number 2, and this number 3. Okay, because of the high mass. Okay, and it's all positive one, positive one. Now, remember, now there's something we can say that the angle of deflection is proportional to Z. It's a charge, or E, over mass. Okay, but the radius of deflection is proportional to what? Root of M over Z. See that? Okay, so there are 2. Right? Think about it. I want to explain some more. Mosquitoes. Okay, let's look at some examples. Okay, 28 there. Okay, look at some of these examples. All right, here, 28. Very simple questions. Okay, the diagram shows the possible path of subatomic. They use the word subatomic particles. Right? Which means what? Which means it's electrons, as you can see here, electrons, neutrons, and protons. Okay? Moving in an electrical field. Remember, it's not a magnetic field. Magnetic field only for mass spectrometer. In a vacuum, why vacuum? There are no particles which is causing it to collide. Okay? So it's free movement. So obviously, electrons will move towards a positive pole, which is correct. Right? But now they want the angle as well. Neutrons, of course, not deflected, right? Going straight. Protons, of course, will move towards here. Cannot, it should move towards here then. Okay, and the angle here should be less than this one here. Okay, so of course it's 1 and 2, which is correct. Okay, now here you can see another question here. Protons and neutrons have been used in nuclear reaction. After I want to talk about some of the nuclear reaction. Remember, in chemistry we talk normally about the electrons, right? Gain and loss of electrons. Okay, but sometimes like here they also talk about nuclear reaction. Means that neutrons are shot into the nucleus and cause it to break or to combine or fission or fusion. It's a very simple one. I will show you how they ask the question. Okay, so be prepared. Right? Even though it's not stated there, but they can ask you, but they give you some hints, which means you think on the spot. Okay, so protons and neutrons have been used in nucleus. Now, so what is nuclear reactions, right? Okay, that means inside the nucleus, not electrons. Okay, which result in the formation of artificial elements, which is true. You learn in physics, I guess. In such a process, protons and neutrons are accelerated to high speeds and fire as bullets at the nucleus of the atom of an element. So that's why neutrons are more effective than protons, than bullets. Why? First, of course, they are what? Neutral charge, right? So I think I got the, okay, because they are, neutrons are, well, no charge. Okay, so therefore, no repulsion, I must say, no repulsion. With what? With electron in the orbitals or attraction, of course. Basically, it's with the protons in the nucleus, the positive charge protons, but they're still in nucleus. Okay, so you put everything down. The examiner have to give you marks. In some cases, the neutrons are fired at the atoms of element. Neutrons becomes part of the nucleus. Okay, that means they combine. After I'm going to show you how this happened, right? What effect if they combine together to form a new particle? What effect has the presence of extra neutron have on the chemical properties of the atoms form? Right? No change. Why? Chemical properties depends on what? On the electron distribution. Chemical property, no change. Right? So 2 marks here. So no effect. Why? Because chemical properties. It means chemical reaction. Chemical properties. Okay, depend on what? On electron configuration or electron distribution. Okay, no? Electron distribution. Electron distribution. So number of electrons, no change. Number of electrons, no change. Okay, basically it depends on the outermost shells, the octet and so forth. But let's look at the harder of the 2 or 3 harder ones. Okay, let's look at the 2. Let's look at harder ones straight away. I may not have time to all these things. You can look for 2H, 2H, 3 and 2. Sorry. Okay. Okay. Now here we are on top here. This thing is berserk. Okay. This is a very nice question. B31, okay? Beams of charged particles are deflected by an electric field. Okay? So beams, well, that means here, don't assume it's electrons or protons only. See now here there's a whole series of them. Okay? Right? Okay, electric field. In identical conditions, the angle of deflection is angle of deflection, which we say is proportional to what? Proportional to E over M, is it? Right? Okay, the charge. The bigger the charge angle here, the bigger the charge, the bigger the deflection mass. Right? Smaller the charge, or the bigger the mass, the smaller the deflection. Okay, it doesn't matter. It's all about the ratio. Here is right, because there are two things here. Proportional, they tell you. So they tell you is charge over mass, because you don't have to memorize it, because it's not in the syllabus stated. Okay, so ratio of charge over the mass, right? Or you put Z over M. They tell you. Okay, in experiment, the protons are deflected. See, protons are what? Are one, is not, yeah? Right? And it's charged positive. Protons, okay? Right? Actually, P or positive. Proton is 1, 1. Okay? So deflected by angle of the sun here. Okay? So protons H 1, 1 positive right now. Okay? So of course, if you see the angle proportional to, right? They say here we charge E over M. So what's the charge? Positive 1 over 1 is equal to positive 1. Okay? So now, which is how much? Which is proportional to positive 15. That means on, why positive? That means it's on the, well, it talks about, okay, on the side here, okay? It's negative. Negative is positive, means it's going inside here. Okay? This side is positive. So this angle is 15. Okay? Just on this positive thing means this direction. But this, of course, is the poles of the electric field. Right? So in our experiment, identical conditions are particle Y. So particle Y, okay, so which one is particle Y here? Okay, particle Y is deflected by -5. That means it's on the other side. It's only 5 degrees. That means it's on the negative side. Oh, sorry, the positive side. Okay, it means this side is negative, isn't it? Right? So the negative and positive, the negative, see the negative and the positive tells you the direction as well. Okay, so now you have to work it out. So Y, if Y is, okay, now if this here, 1, 2, 1, 1, 2, 2, that means, right, the total mass, how much? The total mass is 1 plus 2, isn't it? Which is 3. Okay? We take the mass, we don't care about the proton here, don't care. Okay? Protons don't care for the charge. So 1 proton and 2 electrons, so what's the charge? -1. See that? So the angle is proportional to -1/3. So what is the angle? Question mark. So it's it's number 1. Number 2. Why? Total mass is 6, right? 6. The charge is +3, -5. So what's the total charge? -2. Yes, not. So the angle is proportional to what? Total charge is what? -2. Total mass, how much? 6. Oh, using same, 1/3. So question mark. Okay. So the third one, number 3. If Y is what? Okay, 4 plus 5, total mass is 9. So you work it out. Here's 4 positive and 1 negative, so it's plus what? Plus how much? Plus 3. So obviously this will be on the same side, okay, towards the negative pole. So obviously this will be so it's proportional to, you want to do lah, okay, equal, sorry. Oh, sorry, what am I doing? Stupid, right? Okay, now mind. Everybody can be stupid at some time, so I'm stupid today. Okay. I see. Hurry, and give me all the stupid mistake. Never mind. I've got reason. Okay, let's get this. Where is my? See, I cannot move the floor. Okay, never mind. So, what proportional to? What is this? What is the what is the total mass is 9 over what? Over 4 and 1. It's plus 3, isn't it? Plus 3. So it's actually plus 3. So obviously it must be this and this is correct, It's quite simple. So right? Plus 1. See here, I put red pen, so you can see here. Right? So plus 1, the value plus 1 is plus 15. So minus 1 over 3, how much? So 15 over 1 times 1 over 3 now. Okay? Yeah. Right? So this is minus here, so it's 5. So it's minus 5. Okay? Right? So now this is how it comes out in this form, which means you need to do some calculations. But they actually tell you what is the alpha they're proportional to. Okay? Wait, let's write down something first. Okay, correct. Now let's look at a few more, well, 2 more questions that you want to see. These are simpler ones. 402. Okay, you can see here. Okay, now this is quite simple. Neutrons are passed through electrical fields, neutrons and electrical field. Okay, the mass of neutron is relative to 1 over 12 mass of carbon. Okay, which means 1 over 12 of mass carbon 12 is 1 over 12 times 12. Remember we did this before? 12 times 12 is equal to 1. Okay, which means 1 AMU unit. Atomic mass unit. Okay, 1. So which means same as the neutron. Also 1. And any deflection in the field is recorded. Blah blah blah. So simple. Can be or B or D, isn't it? So behavior of beam obviously not deflected. Simple, isn't it? Last one quickly. All right, deflection 360. 360. And we move on. 360. Okay, here we are. This is even more simpler. Beams of protons, neutrons, and electrons have behave differently in electrical field. See again, electrical field due to their different properties of mass. Okay, so the diagram shows a beam of electrons in the field. Okay, they show the electrons here. Add label lines to represent parts of protons. So easy, but you must know that the answer. See, so you must be careful. This is the neutron. Right. Now this electron, isn't it? Now the proton deflected. The angle is important now. This alpha here. The angle will be less or more. Less, why? Because heavier, must be less. Must be shown less proton. I think I got the marking scheme here. Let me have a look. Okay, 16 million 12. 16 million 12. 16 million 12. Very good news. This one. I think so. 16 million 12. Nope. Or hidden. Nope. Never mind. Okay, it's quite simple, isn't it? All right. Never mind. I don't want to waste time. Okay. So now we have covered that already. Now let me show you some questions on fission and fusion. Okay, which is very simple. No worries about it. Just want to bring out this whole thing, finish off. Okay, then we move to the moles already. Okay, which later the calculations of. Now for fission and fusion, which means they're going to shoot into the nucleus. So nuclear reaction, okay? So notice I got just three questions here, okay? 372. All right, I can see how they're being asked. Okay, now here, right? When nuclear reactions, so they tell you is nuclear reactions, which we don't actually learn. Okay, we learn chemical reactions only, right? Like oxidation, reduction, all these things, right? Takes place. The electrons produced, so the elements produced are different from the elements that are reacted. Nuclear reactions, such as the one below, are used to represent the changes that occur. So remember, see now, uranium 923235. They tell you the mass number, the proton number, okay? Right? And neutron, neutron, the mass 1, is it? So neutron is mass 1. Proton is 0, okay? So now they form these things here. You can see barium 561, blah, blah, blah. Now remember the total mass is not destroyed, it's just changed. The total things here and here should be the same, which means, right, this is 235 plus 1. Okay, now this is the total number, the mass. The total is what is equals to 236. That means that the top here must be the same. It's 144 plus 89, and it's 3 neutrons, so it's plus 3. You see the same, is it? No, right? 7, 6 equals to 6 and carry 1 and 3 and 2. See, same. The number is the same. The bottom also same. This is 92, isn't it? 92, the total because it's 0, man. So it's 56. 56, okay, 56 plus 36 plus, okay, 3 times 0, 0. Okay, 92, 0. Okay, so the nuclear mass here, use what nuclear mass, nuclear number. Total is 0. They tell you, so nice of them. They tell you also this 92. Okay, now another reaction. So which means that if something is not in the syllabus, they will tell you the theory. Which means you have to use the theory there and there. It's not very difficult. I know it's a simple one. So I say in A levels, they would dish out something new to you, or something you heard before in physics, whatever. Then they will ask you to solve it using your brains a bit lah. If no brains, just too bad lah. You just get 0 lah. What's the problem? In another nuclear reaction, uranium 238, 235, 238, it does in form 5, right? It's reacted with deuterium 21. The isotope of the new element J is formed as well as 2. Okay, simple as it. Right? So you just use the whole thing here. The total here, how much is it? The top part will be 238 plus what? Plus 2. How much is it? 240. The bottom one is what? Sorry, I'm going to hurry. 92 plus 1? 93. I don't know. Yep. So here's 2. So remember the top part is 2 plus what value here is equal to, it's all maths, isn't it? 240. Obviously x is equal to how much? 238 as on. Yep. And the bottom part now here, right? Remember here, isn't it? The part is 0, isn't it? So how much is 92, right? Not 93. So U is J is what? 240, and the bottom part is what? The bottom part is what? 99. Remember 93. Okay, now which one is correct? So now there are 2 things here. So how do you know which one is correct? Look where? Look in the sky. Look in your eyes. Look in my face. Idiot. Of course, look in the data booklet. That's why you must have your data booklet. Okay. All right, now let's go down here. All right. So you have to know where to look for. The data booklet is given you in exams, not to paste on the wall, no, paste in your face, Right? You need to use it properly. Okay, now here, sorry. Okay. I turned it just now. I didn't turn back because I want to use it upright. Okay. All right. Now let me just use this thing here. Okay. Done. Where is turn to? This computer is okay. Salah punya. Okay, now let's look at this again. I don't know what number is it. 240, isn't it? Right? 240, 240, 240. Now down here, 240. Look at this thing here, 240, 240. Where is it? 240. Any 240. I didn't look at this just now. Sorry about this. 240. Okay. Right now, 238. All right. So around here, these two fellas here. All right. So now, can you see that these two fellas, 93 and 94. Okay. What is the thing here? 90. What? 93 is it? Yeah. So 93 is where? 93 is your Neptunium. Okay, NP, see? Why does not work? Funny, this is first very funny. Okay, never mind, we'll make it work. 93. Neptunium, alright, whatever the name is. Okay, so is the answer will be C. Got it? So you have to combine all these things with your data bullet and your, how smart you are using these type of things. If you don't use your data bullet, then you die, you idiot. Can't even learn simple things. Okay, next one, last one. Okay, fission. I got 3. Okay, did we do this one? Okay, 360. 306. Sorry, 306. Okay, 306. This computer service it goes up and down. Wrong things. Same thing here. Right? So I won't go through this. You can go and try yourself. It's the same idea here. Okay, the idea, the total here is same. Okay. All right. Just show you here, and one more 417. 417. Okay. So remember, this thing comes out. Wait, 417 don't have 417. Never mind. Okay, I don't know where I put wrong name. Okay, never mind. Right, so you can see nuclear fission does come out. Okay, now let's go next to, of course, now I finished all these things already. Now let's go back to the syllabus and see where we are heading. Always look at the syllabus and, okay. Now I finished 1.1, 1.3, now I'm going to do 1.2. Famous one. Remember, mole idea, the mole, okay? Right, the mole. And Avogadro's constant. Remember, the mole comes out quite often in Form 5 IGCSE on definitions. It comes out once a while here, right? I found one or two only, okay? Define and use the term mole in terms of Avogadro. Now let me tell you, okay? Avogadro's constant. Now in Form 5 you can give a few different definitions, but here they don't want. They want in terms of Avogadro's constant. Remember this, A levels is different from IGCSE, okay? So how they ask you is, you can see the marking scheme now, right? Define, okay, and use. Okay, I'm going to show you a few uses. Okay, now mole. Now let's go to the notes in page 19. So I plan on my work again. Okay, the plan is plan to fail. 19. So I make it faster. I know my video is very long, 1 hour, but what to do, right? You don't have to. If you cannot take it everything, don't take whatever you can and then go back to it again See now, right? I said I'm not making money. It's all free now. This is like a tuition, free tuition, man. My goodness, I can get A-level free tuition for you. You fellas are damn lucky. But I must thank my students though. Actually, it will help me to do all these things. I'm a very stupid fella with all this computer one, but my students, Gloria asked me to buy the Huion, something's RX 64. That's very good. I can use the tablet. No, otherwise I'll die, man. I'm not gonna do this. It's too difficult. But now again, and if I teach me how to unload this whole thing into the YouTube, and I first try to put in the Google. Take me 45 hours to download one video. No, my goodness. Now YouTube's so nice. All right. So Brian also helped me a bit here and there. Of course, the students all prompt me. I must thank my students. By your students, you are being taught. That's what in Sound of Music that you say. Okay, now mind. Now, the mole. It's not the animal, or not the mole in your face, okay? The mole, right? and alcohol. Now, in Form 5, you learn these two things. I always tell my students, well, mole. Today we're going to learn about the mole, because the mole is a starting point for calculation, and I tell you, it's lots of calculation. So you better know this concept well, otherwise you will die, you will fail. I'm just telling you the honest truth, right? Now, mole, I will say always, do you have a coin? Take out your coin. Take out a coin. Take out a coin now. Fools. I tell you what, ask you. Okay, your coin? Do you have a coin? You off the video and go and do something stupid. Okay. I got a coin. Now, put a coin in your hands. Have you done that? Make sure don't cheat me, okay, you idiot. Now, how many faces are there to the coin? Two same one or two different one? Two different, idiot. One's the head, one's the tail. Okay. So same thing. One coin or one mole has got two definitions. One very important. So the first definition, of course, is you learn in calculations that is what, remember here, it is the relative atomic mass of an element, right, expressed in grams. And that's the first idea here. Relative atomic mass means atomic here means for an element, isn't it? Okay? The element can be H or H2. I'm going to tell the difference, okay? Right? That means that if it's H, is the AR of H is 1 gram, okay, or 1.00 to be very correct. In A levels, they will ask you for 3 sig figures or 2 decimal places. If it's H2, right, you can say it's M lah, okay, MR is equals to 2.00 grams, It's not, because 2 is the AR or the MR is in grams, Now this is for an element. It is also, remember, it will have to be the mass. It's the mass. Okay? There's an amount. I'll show you after, this is important. See, A levels is very English. It has to be what is from England, like you idiots. Okay, amount means is measurable. And grams, okay? See that is AR or MR expressed in grams, not catties, not in pounds, not in whatever. I don't care, okay, in grams. That's why SI units always in grams, in kilograms, okay? It's in grams. Or it is the, of course I should put here, it's the relative molecular mass, okay? It's a relative to be perfect, okay? Molecular mass, right, of a compound expressed in grams. For example, H2O, okay? Right? So it's the amount. So remember, the relative molecular mass is what? Okay, so 2 times 1 plus 16 now, right? The MR is 18. MR has got no units. Why? No units. Why no units? Because it's a comparison. I'm 200 kilos, you are 100 kilos, right? And there's an exact value. But I'm 2 times heavier than you. So I'm 2, you are 1. I don't have 2 grams or 2 kilograms. It's 2, isn't it? 2 is a comparison. So it's comparison. Okay? 18. So if I put grams here, it means this is 1 mole. Okay? So it's MR. Now, that is the first definition. In Form 5, you learn this. I hope you know this. I tell you, you don't want to go back to Form 5 or Form 4. It is also a number. If you want to express it, it's 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. It is this number, no? It's how many billion, trillions, I don't know. No. You put a comma here, right? If you got this amount of cash or this amount of kilograms in gold, wow, you're the richest man in the whole universe, okay? This number, how come so big number one? Where you need so much number? You need this kind of number. As how many sand in the ocean? You can't count it out. Things are very small, you need this kind of numbers. How many cells are there in the whole tree? Millions and millions. So when you talk about chemicals, there are so many small atoms and ions. Okay, so it's a number. And this is called Avogadro's number. Okay? Avogadro's number, or now it equals Na. This is the symbol. Don't use okay, no more use on. Right? So this is Avogadro's number. It's a number. Like 1 dozen is a number. 1 dozen means what? Means 12. 12 what? Well, whatever is it. There's no 12 grams or 12 kilograms. It's 12. So 1 more, what's the number? 6.02 10 to the power minus 10 to the power 23. It's a number. How do you put these two together? In Form 5, you can put them together. Right? It says that you can put them separate like that. So it should be. The mole is the relative atomic mass of the element, which contains 6.02 times of 23 number of atoms. You can say that in Form 5, right? Or you can say in the molecules now. But Form 6, 2014. Now look here. Amount of substance. Definition for 1 mark only now. One mark, I tell you. All this difficult, but it's very accurate. See, CIE gives you a very accurate definition. You can thank them for fantastic English. It's the amount of a substance. Now, let me explain, okay? Amount means measurable amount, okay? Of course, it's in grams, not kilograms, huh? It's how many grams of a substance? Can put kilograms, just convert lah. The substance here can mean what? Can mean element, or a compound. Okay, I'll show you after all. Okay, all right. It's the amount containing 6 point. So they don't have to put point, but it doesn't matter. Bracket means up to you lah. Okay. 23. I've got some saying fundamental particles. Now particles are the smallest substance. Smallest substance in the element or in the compound. Smallest substance. Smallest substance. Or particle, they call it substance. Okay? Of course, if it's element, what's a small substance? Atom. If it's compound, what's small substance? Molecule. See now? Okay? If it's ionic compound, it be positive ions and negative ions. Okay? So it's the amount of substance. So to be perfect, you include everything in. Amount means substance will include elements and compounds. It's the amount of substance containing Avogadro's number of particles in the substance. Full marks. Okay, the other one is a bit too tough, I think. Okay. Now I won't go further. You want me? We can discuss in class all the various things. Like for example, okay, just give you the example. Okay, I'm just going to do here. Okay, like for example, right. This one you learn Form 5, right? If you have not learned that means you are an idiot. 1 mole. I don't know why it doesn't work sometimes. Never mind. Maybe I did something wrong. 1 mole of H. These atoms are, right? Is how many grams? 1.00 grams. Okay? Now also in 1.00 grams, it will contain 6.02 times 10 to the power of 23 atoms of H. 1 mole, element again of hydrogen gas, these molecules. And how many grams is it? 2 grams. Will contain how many? Same. Molecules of H2. Now, and in this molecule, it contains 2 times 6.02 times 10 to the power of 23 atoms in it. Okay? Right now, I go over this by yourself. I'm not going to go over here, no time already. Okay, now you got 1 mole of water. This is a compound, 1 mole of water. Okay, how many is this? 2 plus 16 is what? Is 18 grams. Okay, I'll put it 18 grams. Okay, you cannot do it, you go and do it, ask me later. Will contain what? What are the particles? They are molecules, 6.02 to the power of 23 molecules of H2O2. And in this one here, it will contain how many atoms of hydrogen? 2 times 6.02 times to the power of 23 is it. How many atoms of oxygen? It will be 6.02 That's all. Okay? So you don't know, look at this example, and then you're going to figure out a copper sulfate, ethanol, all these things. Can? All right. Now, for one question here, I always ask my students to do one. Here. Okay? What is the mass of one atom of carbon-12? One atom. How many say 12? 12 grams. You idiot. How can one atom weigh 12 grams? Right? Now, here is where you use the idea of mole and things to find one atom of carbon-12. Okay. Right? So they ask you, of course, you can calculate this in two ways, right? One way is from the fundamental particles, and one way is from the Avogadro's constant. Right? Now, I'll show you what I mean, okay? If you don't know, all right? Yeah. Okay, I need to reverse back again, okay? Yeah. Okay, let's go to here. Always learn how to use a data booklet, okay? You don't learn to use what page is there, then you are at fault because they gave it to you. They say you are supposed to have this. You're supposed to know how to use which page. In A2, everything, all this will be used. AS, some of this will be used. Now here, see? Now this is the first one, constants. See? Avogadro's constant. Oh, it's L now, sorry. L. Right? For per mole, it's the number. Okay? Right? Now, of course, if you want to count from fundamental particles, you can count from these three things here. Because carbon-12 consists of 6 protons and then 6 neutrons and 6 electrons. So one proton, the mass is this one here. So it's here's with 6 times this fella here, kilograms. Okay, 6 neutrons also times 6 n. 6 electrons times 6 n. Okay, so this will add up. This is from the fundamental particles. You calculate them for one atom. One atom now, my friends. One atom, not 1 mole. Okay, 1 mole is 12.00 grams. One atom of carbon-12. Do you understand what I'm saying? Okay. From fundamental particles. Fundamental particles. Okay. Okay. Now, you want to count it from Avogadro's constant. Now, I'll show you how to do it. Okay. So now here we are. Okay, I've used blank here. Remember, 1 mole of carbon-12 weighs how many grams? 12.00 grams. Okay, and contain 6.02 10 to the power of 23 atoms of carbon-12. Or you can say, reverse it, 6.02 10 to the power of 23 atoms, right, of carbon-12, right, weighs how many grams? 12.00 grams. So one atom how much? Can do that, right? Should be 12 over this one here. And you find the answer. The difference, now this and the earlier one is different now. You learn in university, why are they different? So after, if you have God, which none of you are God, God Almighty says, okay, 6 protons come here, okay, 6 neutrons come here, 6 come here, and they all combine. Now individually, without combining, they are this number. After combining, the mass changed. No, the mass is decreased. No, you go and count. I challenge you. There's a decrease in mass. Where did the mass go? Remember, scientists say that mass is neither created nor destroyed. No, before and after should be the same. But the mass is lost. Interesting, isn't it? And that's called binding energy. That's what happens when you have fission. The bomb energy is given out for one atom. And how many atoms? How many grams? The energy is fantastic, man. Okay, fission and fusion. Okay, now look at that. Now that's called binding energy. Look up yourself. I won't tell you. Binding energy. Okay. the mass loss is converted to energy, and it's a lot amount because this is only for one atom, right? Okay, I've finished this part here. Now I've got about 20 minutes more. Okay, now I'm going to talk about empirical formula. Okay, we go according to notes. Actually, I've got something else here, but never mind. So remember, now you look at the syllabus. Okay, one. Okay, now we are approaching calculations already. Okay, I finished 1.1, 1.2, 1.3. Okay, right? Now 1.4. The calculation of empirical and molecular formula. Now this is, I'm going to talk very simply. This is Form 5 work. But later you see that after we done this 1.5 here, when you use about solids, see, you have to do calculations in solids, gases, and solutions. Okay, this we will big chapter here. I hope to finish in 2 sessions. Okay, or maybe 3. I don't know. We need to do a lot of examples. Okay, but doesn't matter. We will get it done. All right. So here they ask you to do, first of all, remember the formula. Right? Molecular formula. Earlier was relative molecular mass. Molecular formula. Okay. They ask you first of all to define and use. Okay, empirical formula and molecular formula. Now, same as the Form 5 definition. But so far, I checked, I couldn't find they asked for empirical formula. They asked for molecular formula before. Okay, now let me show you how they ask for molecular formula. Okay, and now my notes is sufficient. Okay, page 34. 34, okay, you can see how they ask. Right? This 34 here, this computer upside down. Okay, what is meant by the term molecular formulas? You know, for 2 marks, you know? Right? For 2 marks, yeah. Now, let me give you the what? Okay, 10. I think it's here. No, November. I must show you this because it's very important. No. Is it? No. Ah, 10 is it? No. Molecular formula. Nope. 10. Molecular formula. Yes, this one. Okay. Now remember, they ask you for molecular formula. Okay. Now I'm going to keep this here. Well, let me just remember here. Okay. Let me just show you my notes first. Okay. My notes is molecular formula. Up here. Sometimes I should put a page down, doesn't matter. Okay, here we are. Now, empirical formula first. You see, both of them are about the same. I put them smaller so that you can compare the idea, okay? Now, empirical formula is the simplest, first of all, it's the simplest ratio of all, it's the simplest ratio of the number of all. So the first thing, of course, the thing here called simplest ratio. First mark. Okay, but actually combine with here now. Simplest ratio of the number of all the elements. Okay. So simplest ratio what? Not of cow dung, not of human dung, not of pigs, not of angels, not of you. The simplest ratio of the number of all the elements. For example, okay, C8H16O2. Now let's say this is the molecule, this is a formula of some organic compound. Okay, simplest ratio of all the elements. So in this case, how many elements are there? There are 3, isn't it? So it's carbon here, hydrogen here, and oxygen. Now the number is a number. The number is 8, number is 16, number is 2. They want the simplest ratio. So all divided by 2, isn't it? So it's like 4, 8, and 1, isn't it? This is called the empirical formula. Present in one molecule of the compound. This is the one molecule. It means the original one. One molecule. Okay, that's the simplest ratio. So when you memorize it, it's the simplest ratio of the number of all the elements. You must say one shot. This is how you should memorize things. Okay, what's for empirical formula? First, number 1, put your thumbs up. And all put your thumbs up. Thumbs up. It's the simplest ratio of the number of all the elements present in. Number 2, second finger up. okay, in one molecule of the compound. Now let's look at this molecular formula, right? It's the exact number, okay? The simplest ratio and the exact number. See, the two different things is that, okay, this simplest ratio, this is the exact number. You can see afterwards the definition of atoms should be the same, okay? Numbers of, right, of simplest number of atoms, okay, equation number of atoms of different elements, see, right? You can say simplest this is the actual number of atoms and of the elements, okay? See here, actual number of atoms of the different elements of all. Can put all, okay? You want to put same here, all present in one molecule. See, same way. See. Now look at the marking scheme. Okay. Actual number. Okay, a little bigger. Some of you are blind cows. Actual number of atoms, of each element or all the elements present in one mark. In what? One molecule of the compounds. Actual number. So if it's empirical formula, it's the simplest ratio, okay, of the number of atoms of each element present in one molecule of the compound. You just change its actual number to simplest ratio. Okay, very simple. Of each element present in one molecule of the compound. Okay, so learn by heart. It's 2 marks, worth learning by heart. Unless you don't want to mark. Okay, you want to fail, go ahead. Oops. Right? No one is going to make you pass. You want to fail, that's a prerogative. Now, let's see how they calculate now. This is Form 5 work, right? Now, I'll show explain again. You can read some of here's from book, okay? All right, you can read it up by yourself. The formula of ionic compound is always the empirical formula. Empirical formula for molecular compound is simple. For simple ionic inorganic compounds are one same. Only for organic substances they are different because they have to conform to a general formula. Okay, you can see from here. Okay, right? I won't go through that. Okay, significant figures can also read through this. Okay, rounding up, and rounding down. Okay, this 5 to 6.8. If it's 36, it's 52.7. Okay. If it's 2, it means you cut down 7 to make it 3, you have 53.0. Okay. Now here, okay, this is one is it. Now it's electron is 1/183. I do that, isn't it? Or sometimes put 1 over. Sometimes you round it up to 1/2000 or 0.0005, I think. Okay, compared to all this. Okay, this is also used. Right? Please look it up yourself. I won't go through that. Now this is very simple. This Form 5. I just go through one of them. Okay. Now, okay. I go to the one that needs some adjustment. Right? Question here. Okay, question 4. Okay, then I go through some past questions, and this don't have time to calculate, or I hope we can have time to go to the combustion idea. Now, they say iron, 5.6 grams of iron reacted complete with 10.65 grams of chlorine. What's the empirical formula compound? Okay, and molecular formula compound. Remember. N times molecular formula. Okay. Sorry. I say Simon Line is stupid. I tell you. N times empirical. Tell you why this is not working. Okay. N times. Okay. Empirical formula. This Form 5 where? Empirical formula equals to molecular mass. Okay, now this one you must know. Right now, here you can see that the compound contains only iron and chlorine. Okay, so normally I'm going to put down here because of space. Right, this Form 5 work. Okay, now iron Fe here. I can put anyone, doesn't matter. Chlorine here. There are 3 things here. First is mass. Remember, follow this on here. You've got no brains for this on here. Mass, moles, and 3 ratio. Easiest. So here's in grams. Okay, so here's 5.6, 10.65. 0.63. Yes? Number of moles, remember, is equals to, of course, mass over AR. Okay, so we learn again later. So 5.6 over 56. 10.63 over 35.5. Okay? This is equals to 0.1. Okay, let me just calculate. I didn't calculate yet. 10.63 divided by 35.5 equals to, what is this? 10.63 divided by 35.5. Okay, is equals to 0.2994. Well, approximately 0.3. Okay. So ratio, you take the smallest name, right? So 0.1 divided by 0.1 equals to 1, 0.3 divided by 0.1, 3. So it's Fe. So the empirical formula is FeCl3, right? Ask for molecular formula, the exact number, right? So N times FeCl3 equals to Mr. Equals to how much? 325. So you put on the N times Fe is what? 56 plus 3 times 35.5 bracket equals to 325. Now, N, okay? 56 plus, okay, let's do it, 35.5 times 3. This 106.5 equals to 325. That means N is equals to 325 over some plus 56. 162.5 is approximately 2. Okay, so what's the what's the molecular formula? Interesting, isn't it? It's Fe2Cl6. It's a dimer. You can see later why, because FeCl3 is covalent. Interesting. Got one question here. Okay, later. Okay, so quite interesting, right? So now remember, this is how they do it. You can do the rest of it. Now I want to go through. I've got about 10 more minutes. I want to go to some questions here. Okay, right? And then you can look at the, okay, how they come out. I thought of doing something else, but no, never mind. Okay, 217. All right, is it 217? Okay, 217 here, number 1. Is it? Oops, sorry, man, I don't know what happened. 28289. I must have changed it or something. Never mind. Here. An investigation of the reaction between magnesium oxide and hydrogen chloride gas shown. An intermediate product is formed by composition of this blah 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 blah. Remember, if you give percentage here, you change to grams, okay? But all the percentage add up to 100%. 31.65 blah 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 100%, okay? Coming and the formula, okay? Easy then. Obviously, I said told you before, right? So there are 1, 2, 3, 4. So put on here 1 magnesium. Okay, second column oxygen. Third column hydrogen. Fourth column. Now this form 5 work. This any fool can do. Okay, mass moles ratio. Mass moles ratio. You don't know. I think you better go back to form 5. Now it's in percentage. Change all the grams. You know. So if it's 100 grams, how many grams is simple 31.65. If it's 100 grams, how much is 20.84 grams. Hydrogen is 1.31 grams. Chlorine is 46.2 grams. Okay. Now change it to moles. Will be 31.65 divided by 24. I'm not going to do this again. You can do this way simple. 84 divided by what? 16. 1.31 divided by what? 1. 46.2 divided by what? 35.5. Then if you find the things here and you take the smallest number, you divide all by the smallest number, then find the ratio. Okay? Okay, simple, isn't it? All right, let's get another one. 5 more minutes. Okay. Okay, 308. You should see how they ask. 308. Oops. Nothing. Okay, yeah. Same again. All right. Analysis of another organic compound B give a following composition. Okay, carbon, hydrogen. You can say add out 64 point plus all this is 100%. Cover the empirical formula. Cannot. Can do, huh? Okay. Again, quickly, so you put put a column here. The first column is carbon, second column is hydrogen, the column is. Now this one, if you don't know, I think better change cost. Mass, moles, ratio. Cannot. Okay. Simple as it. Okay. One last one, then I think I will talk about something else. Okay, 308, 348, 348. Then we stop. 348. Yeah. This is very interesting. This is very interesting. Okay. Well, we actually not say very interesting. Is I think we work through it. Okay. Aluminium reacts with chlorine to form a white solid. Alright, it contains 79.7 grams of chlorine, percent of chlorine and sublimes. Okay, now they didn't tell you the percentage of aluminium, is it? Right? So how do you know? Holding is 100%, is it? So whatever minus 100%. Yeah. So here they ask you to find the empirical formula. Okay, right? Right? Yeah. So here we don't do the first part. So it's aluminium. So chlorine first. How much? I tell you 100%. 79.7. 79.7%. Obviously, your aluminium is how much? Because two things only one. 20.3%. Is it not? Yeah. So the same thing here. Okay. Aluminium and chlorine. Mass moles ratio. Work through it. Right? It's actually Al. You can see Al2. AlCl3. Then later you use this one. We do later. Okay. This one here, and they say calculate the relative, calculate the molecular mass. Okay. And then later they ask you for the. Why is not moving? Later there's one part here. They ask you for the molecular form. Okay. Right. Now I will finish. Okay. Now I'm going to go on one thing here. I will carry on the next day. All right. You see, this very interesting one. This one is I think most of you have not done it out here. I finished 1.4 already, define terms and use, okay, of empirical formula, molecular formula. Now here, I also finished calculate empirical formula, molecular formula, right? Okay, the simple ones. Now here, using combustion data, we have done all composition of mass. We done this already. Okay, simple one. This form 5 carrier. But here, combustion. What does it mean? I'll show you. Form 6. Now this is really form 6 one. Okay. I think I can finish in about 5-10 minutes. Now you bear with me, okay? Full. Okay, now here we are. Let me just put the page here. I say I should have put on the page down. Now it's here. This is new to you. Guaranteed. Guaranteed new to you, okay? And it's they didn't tell you combustion or what now, and I'll show you how it comes in exams, so you are prepared for it. Okay, the whole thing is to prepare, right? Scout's honor. Be always prepared, or be prepared. Don't be always. I say, where's the good do? Here. Okay, now. Right. Look carefully. Calculation of molecular formula. Remember, in this case here, there is we are not doing empirical formula. It's actually the molecular formula. This method is molecular formula of a hydrocarbon. The word hydrocarbon is always asked, even in AS. What's hydrocarbon? The compound that contains carbon and hydrogen. What? Only. Okay, very important. By combustion. The word combustion. What came out in the exam is commonly this one here. They also ask you for alcohols. Later I'll show you tomorrow or whatever. Okay. Now, okay. So now here is the combustion, right? is complete combustion. I will now just do for you the balance of this equation, okay? Right? Now remember, so we start with 1 mole here. Okay? Hydrocarbon. Carbon and hydrogen. So we don't know the formula. Put X and Y, okay? Unknown. And so plus oxygen. Now, how do you get all these numbers here? Okay? Right? I'm going to show you how I got it. Alright? They actually ask you. Okay, I'm going to do here. You see? Now, the stoichiometry of the equation always start with 1 mole, CXHY. Combustion plus, I put a space here, O2. Now remember, it has to be complete combustion. So in complete combustion, you get what? Carbon dioxide and water is here. So get CO2 here. Plus water here. I'm going to give some space here to balance off the stoichiometry. If we start with 1 mole here, right, 1 mole here, how many atoms of carbon? X in it. So here must be X, because it's only product with carbon. If you start with 1 mole here, hydrogen here, and the only hydrogen here is water, is not. So it's Y here. So to have Y here must be Y divided by 2, is it? Right now. Y divided by 2 times 2 is Y, is it not? Okay, that's balanced. Now the whole thing is to find what is this one. Now put A here. Or in the question, they put Z here. Doesn't matter. So now here, if this is X and Y here already, so here, from here, all right? So I know that it's A here. So on this side here, the total number of atoms of oxygen is 2A, isn't it? Is atoms of oxygen. Equals to how many here? Okay, from carbon dioxide is 2X, you know, okay? This is atoms of oxygen. And from water is how much? Y over 2, you know, okay? Okay, right now, of oxygen. So 2A is equals to 2X plus Y over 2. So what is A equals to? A equals to 2X plus Y over 2 divided by 2. To put it nicely, it will be 2X over 2 plus you split out Y over 2 times 2. You know? So it's equals to what? X plus what? Y over 4. That's why it gives us this equation. Okay, now, all right, so here would be, so you want to put out here, your A here will be what? Let me rub up this one, okay? So we'll stop here. So here would be C, why I don't have, oh, I put blue now. So it be CXHY plus what? The whole thing is X plus what? Y over 4. O2 gives you what? X CO2 plus Y over 2H2. Now this is the basic equation. You have to memorize it or derive it in exams. Sometimes they give it to you. Okay? See X over Y. Okay? Look here. See now? See? Okay? Right? Because time's up now. I'll show you. I'll show you the question first before we'll continue this next lesson. Okay? I'll show you how it comes out just on this formula alone. Okay? This formula. Okay. There it is. I say. Okay. 334. Just the bottom here. Okay, so you see this? Complete and balance the following equation. Still see? Okay, see it. Okay. Another one. 358. Something is a bit different one now. 358. I'll let you see how it comes for exam so that you would actually know. Don't be surprised by it. See? Right. Yes, for it's not. You see? Okay. Right now, this is only for hydrocarbons. 1 year came out. Not this one here, right? Not this one here, but it came out in alcohol. I don't have it. I was searching and I found this question. I thought, oh, how can I not see this one here? Not here. Okay, not here. You see this? Combustion here. You see? We will do this next week or next week or the next day, tomorrow, whatever. See? So all these calculations will be done the next session. I see you. Okay. So. well, I've talked enough already. So we have done quite a lot today. You have to go over it, reproduce it. Don't just, oh, I know, you know your head. You better make sure you know how to produce it and go through all the examples. Okay, now a lot of work here, right? So I finished and I need to, okay, goodbye. I'll see you. Bye bye. And you fellas put a like in my video, you fellas now put like one. Do not offer nothing like that.